So now we're going to talk about partial sums of arithmetic sequences. And if you recall, a partial sum is when you add up the first certain number of terms. Like, so if you wanted to find S5, that means you would add up the first 5 terms. There is a formula for partial sums for arithmetic sequences, and this works specifically for arithmetic sequences. And the formula is Sn is equal to n times a1 plus an all divided by 2. So what you would want to do is you would want to take the first term plus the nth term, divide it by 2, and multiply by n. And that will give you the sum of the first n terms. So if I wanted to find, say, S5, I would take the first term plus the 5th term, add them up, divide by 2, and multiply by 5, because n would be 5 in that case. And that would give me the sum of the first 5 terms. So let's use this in example 1 and example 2. So in example 1 and example 2, we're going to find the partial sum 2 different ways. We're going to use summation notation and we're going to use the formula. So we have a partial sum here for an arithmetic sequence, 615 plus 21 plus 27, all the way up to 117. The problem is that I need to know, if I want to add up these first terms, I need to know what term 117 is, so I know what my value of n is, so I can plug it into the formula. So I don't know if 117 is the 10th term, the 11th term, the 20th term. I need to know what that value of n is so that I can plug it into my formula or put it in for my summation notation. So the first thing we need to do is figure out the number of terms we have in that partial sum. And since we know this is an arithmetic sequence, I can use the fact that I know what the nth term is, and I can solve for n. I know the first term is 15, and I know the nth term is 117. So I'm going to put in 117 because we're trying to figure out what n is. So n, the nth term would be 117. I'm going to put in 15 for the first term. My common difference would be 6 because to get each of those terms I would have to keep adding 6. So now I have everything plugged in and I have to figure out what n is if 117 is the nth term. Well, when I go through and I solve that, I'm going to find that n is 18. So I know now that A18 is 117 and A1 is 15. So I can use my partial sum formula for arithmetic sequences, which is above here. That's this formula here. If I want to find the first 18 terms, because I want to find all of these added up, and I know that 117 is the 18th term because we just figured that out. So actually, let me change this to 18. I want to find the sum of the first 18 terms. So n is 18. I'm going to multiply that by the sum of the first term and the 18th term. So I'm going to take 15 plus 117 in parentheses and divide that by 2. When I do that, I'm going to get 1,188. So here's the sum of the first 18 terms using the partial sum formula above. Now we can also use the summation notation on our calculator. I can set it up. Since this is the 18th term, I want to go from 1 to 18 and add up all those terms. So my initial value would be 1, and my ending value would be 18. My formula for the arithmetic sequence that I would be plugging in to find each term would be 15 plus 6 times x minus 1. I'm using x's now because we're using the variable button on our calculator, but just know that that represents our n. I would plug that in on my calculator and you would still get the value of 1,188. One thing to be careful of when you're putting that in on your calculator, notice we have two sets of parentheses. We have the set of parentheses that encompasses the whole sequence, and then we have this set of parentheses here to put it around the x minus 1. If you don't put your parentheses in correctly on the calculator, you're not going to get the right answer. So be careful about putting in your parentheses. Okay. Now we're going to do the same thing with the second example. We want to add up all of these values, but we need to first figure out what term is 7. Is that the 10th term? Is that the 9th term? Is it the 100th term? We need to figure out what our value of n is so that we can put this in our summation notation or use our formula. So, since I know that an is a1 plus d times n minus 1, I'm going to plug in all the information that we have and try to solve it for n. Since I'm looking for 7, 7 is the nth term, so I'm going to put in 7 here. My a1 is 3. My common difference would be a half. I would have to keep adding a half to get each of these terms. And then I have n minus 1. When I solve that for n, I'm going to find that n is 9. So the 9th term is going to be 7. The first term is 3. And if I use my partial sum formula, that means I'm trying to add up the first 9 terms. So I'm going to say S9 is equal to, my value of n is 9. Then I add my first term plus my 9th term and divide by 2. When I do that, I get 45. So if I were to add up the first term all the way up through the 9th term, I would get 45. So now we can also set this up using our summation notation. When we put it in on the calculator, we would start at the first term and end at the 9th term. And then we would put in our formula for the sequence so that it can generate each of those terms and add them together. So since my first term is 3 and my common difference is a half, I would put in 3 plus a half times x minus 1, keeping in mind that I have the parentheses that goes around the entire sequence, and then I have the parentheses that goes around the x minus 1. So be careful about the way that you put your parentheses in so that you get the right answer. When you do that, you should get 45 as well. So you have two different ways that you can do this. But either way, you're still going to have to figure out what term that is if it's not given to you. And in these two examples, it doesn't tell you how many terms you're adding up. You need to figure that out.